Today, again, excited to have Heather Harmon Disque present about forest health update. She's a forest health entomologist with the Maryland Department of Agriculture and the Forest Pest Management Department. So she's going to share with us all the recent pests and disease. This is our annual, we have Heather come back every year in the fall to present to us on this topic because it's always changing and they're doing annual surveys, and she's going to give us a great update on the state of the forest health issues facing us today.
I am the forest health entomologist. I am also the regional entomologist for forest pest management on the Eastern Shore. So here is our lovely Kent Narrows. You can see there's a forest. We were evaluating it for water damage. So that's kind of fun there. So let's go hop in. So the first topic we're going to talk about today is emerald ash borer. So just as a quick overview, let me see if I can get there's my pointer. So here is the adult of emerald ash borer. Here are the galleries that they cause. We like to call these serpentine galleries or S-shaped galleries. You can see this kind of shape through here. The adults, when they emerge from the trees, they create these D-shaped exit holes. Here you can see two adults emerging. And then while they're making these galleries, this is what the larval stage will look like, and then eventually causing the mortality of the tree. So we've had emerald ash borer in Maryland since 2003. So it's not a new problem, but we still consistently do activities to try to save some of our ash populations. And so what have we been doing in the past year? So we've been setting up adult traps. Previously, both Wicomico and Worcester, we had not been able to pull a live beetle out of those counties, which now is Wicomico in this trap right up here was positive this year. So the populations, our traps are not extremely attractive, but attractive enough that we were able to collect some beetles out of here. Not that the beetles aren't in these two counties, but we just hadn't been able to pull one out. So now Wicomico is positive, leaving just Worcester. You can also see there's some additional adult traps around the state, and those are at our parasitoid release locations. So sometimes, like with the ordering of it all, so there's also adult traps here, and there's also parasitoid release locations here. And so this year we released parasitoids at 6 different locations. So Western Maryland, the upper shore, and then the lower shore. And then in addition to trapping and parasitoids releases, we also were able to treat trees. And so these trees were treated in some of our state parks. And so that's, they were here in, again, the Northeast region. And then we had some down in the lower shore. In addition to that, we had some wildland treatments, which aren't represented on this map, but this is what they look like. So a lot of these wildland areas that we're treating are wet all year round. So you can see there's water laying here. A lot of times they'll start to flood. So you can see what we end up doing is we are treating trees to save some seed bank for the future, as well as to help provide some erosion control. And so here we start treating these trees above the high tide line. And so we treat them with these high pressure units, and we, inside of them, we put emamectin benzoate, this chemical here. So we are using Triage G4. It is a it's environmentally friendly, but not friendly to the insects. And so it has a few different qualities than just regular Triage. Regular Triage is a restricted chemical. And so only licensed pesticide applicators can apply it, but it also has a lot of environmental conditions that we don't have in Triage G4. And so we can apply it in these more environmentally sensitive areas. So with this is done through a trunk injection. And so we use these F-series tree IVs. So inside of here, this is a pressurized bottle that has the chemical in it, which then once these lines are put into trees, then we can open up the lines, and then the chemical moves through the system and is injected into the tree and then moves up into the tree to protect it from emerald ash borer. And this is really important because of the way that emerald ash borer life cycle is that you need to get to the beetle when it's causing the damage to the tree's inner bark. And so that's why we have to kind of get those chemicals inside of there. That's why a trunk spray doesn't necessarily work, and why it is more effective than a traditional drenching, because it is put in, and it's all the chemicals put in immediately into those tissues, and it's not allowed to bind with the soil. So these treatments are done when the trees are uptaking the majority of their water for the season, so in the spring. So we are typically treating April, May, June, and if it's not too hot, the first couple weeks in July. You can see here, we actually did retreat this tree this past year. This is a champion pumpkin ash in Caroline County. So it's kind of, you can see the bases are together. So this is one tree. So it's pretty impressive. And then in addition to that, there are other chemicals, of course, that can treat EAB, and one of those is imidacloprid. So imidacloprid is a neonicotinoid that's used as a soil drench. And unfortunately, that product is no longer available to the general public. You do need a licensed pesticide applicator to be able to perform treatments with imidacloprid. Imidacloprid treatments are typically good for 1 year, whereas the emamectin benzoate is good for 3 to 5 years, depending on your level of EAB.
Heather, we've got a couple of questions coming in already. Can you give us a little background on the trees that the emerald ash borer kills, and the sort of rate of survival and the impact, and how important this is? And I think you addressed one of the other questions that just came in. How often do you treat the trees? It sounds like once every, was it 3 to 5 years? But go ahead.
Yeah, so we retreat trees once every 3 years. Just we stay on top of it, and we keep the majority of our crown. Once populations start to die back and go to really low levels, we might be able to expand it to that 5 years. But for us, we are on a 3-year cycle for all of our tree treatments. And then why this? So emerald ash borer, it's in the name is ash. So it attacks all Fraxinus species. There's a range of ash susceptibility, but basically all of the ash inside of Maryland is extremely susceptible to emerald ash borer. It can also attack white fringe tree. And so the thing with white fringe tree is it seems to have a better ability to heal the wounds over top of the larvae, to be able to stop the larvae from developing completely. Now, not that it can't complete development in white fringe tree, but white fringe tree does have the ability to be able to use those defense mechanisms to build a callus over top of galleries. So, but our ash species do not have that ability. And so what we do with our state lands is, number one, we have developed a treatment program for ash inside of our parks that are either endangered or rare species. So this would be our Carolina ash and our pumpkin ash and black ash. And so we just have very few stands of them. So we tried to treat as many of those as we could to maintain their vigor. But in addition to that, we also took ash that were inside of highly populated areas where they would cause hazards. So, and then in addition to that, then we also had wildland areas where we were able to, like I said before, those wildland areas are more rural. There's not a lot of foot traffic, but it's important to kind of keep those to be able to maintain ash in the landscape for the future, which is in addition to why we do treatments, but we also release parasitoids. And so we release 3 different parasitoids. So we release 2 larval parasitoids and an egg parasitoid. And think we go next. Yep. So I have, here's one of our larval parasitoids here. And so we have been able to release parasitoids across the state. And so the idea is that ash is going to be gone from our landscape in the scale that it has been in the past. But what we could do for the future is to try to maintain a seed bank and then maintain these important species, such as our rare species, to try to keep them there in the environment for the future. And then once we get to a point, so, with all pests, the population grows and then it crashes once it consumes all of the host species. So in this case, the ash. So when the ash go down to that 95, 99% mortality rate, then the EAB has eaten through their food. And so now then we have these parasitoids that while they're doing their parasitoid thing where they're parasitizing EAB larvae or eggs, then they can then colonize what population is left and hopefully control that so that then our ash can regenerate and grow for the future. So that's kind of our hope, is that in the future, we won't have to treat as much because then these parasitoids are going to be in the environment and helping to move around. And we do this work, the parasitoid work, in conjunction with the University of Maryland. And so here you can see there's a whole bunch of people here that have been a part of this parasitoid release program. So of course, my group, Forest Pest Management, Plant Protection, also in MDA, as well as the University of Maryland Entomology Department and the Beltsville Invasive Insects Lab, or not Beltsville, excuse me, the Beneficial Insects Lab from the USDA ARS in Newark, Delaware. And so we release parasitoids and then they do a lot of the follow-up work to see what parasitoids are establishing. And I don't have their research to present to you, but I will say that they are establishing, we are able to find these parasitoids again in these areas where we have released and in areas where we have not released within 5 miles. And then there's even been one report of parasitoids found 9 kilometers away from a release site after 1 year. So that's pretty far for, you can see this really tiny wasp. I mean, this is a number that somebody wrote. It's not big, it's just a regular number. And so these parasitoids are very tiny. So for them to move those 9 kilometers is pretty impressive. And then in addition to that, I just have our map here showing that, yes, Worcester County, we still have not pulled a live EAB from, but we're kind of hoping to be able to do that this winter. All right. Moving forward. So out of EAB land, so Emerald Ash Borer is a non-native to something that is native, the southern pine beetle. And so southern pine beetle tends to have these cyclical moves throughout the area. And so for us, the majority of these cycles have been found in the lower eastern shore, so in Dorchester and Worcester counties. If you remember, in 2014 through 2017, we had a significant mortality event in lower Dorchester County, as well as along the Assateague Island natural areas. And so those probably saw a combined of over 600 acres of mortality of pines. So what southern pine beetle does is they create these galleries. So again, these are also a bit serpentine. So you can see these here. And then offshoots of the galleries are these egg laying areas where they'll lay an egg. So here's what the egg looks like. And then through the larval stages into the pupa and then the adult. So here is an adult southern pine beetle. Here's a grain of rice. And then here is another Dendroctonus species, another bark boring beetle. But this one is called black turpentine beetle. And so actually this one is also native and is usually typically found in the lower portion of the tree. So maybe from the base of the tree to 3.5, 4 feet. And then southern pine beetle is typically found in the mid bowl and higher in the tree. So that's typically where we find these. And what happens is that southern pine beetle has a really great pheromone that they can call other beetles too. And so we call it an aggregation pheromone. And when a southern pine beetle finds its golden corral, delicious, full buffet survey tree, it'll call its other beetles to it using that pheromone. And so then a lot of times what we find then is this popcorn looking stuff coming from the trees. So this is the tree's defense mechanism trying to push those beetles out quickly. And then unfortunately, when the beetles are calling the other beetles using their aggregation pheromones, typically it's like a death of 1,000 cuts. You know, the tree is trying to push them out. It's typically already weakened. Southern pine beetle loves trees that are already weakened. They kind of get that. They also can clue in to the volatiles from the tree that the tree is putting out there, saying that it's not doing well, it's unhealthy. And so they'll kind of all come to this one area, attack, and then typically they can only kill weakened trees. Unfortunately, once the populations really start increasing to a really high level, then they can take out healthy trees. And so one of the other things that they bring into the equation is this fungus, this blue stain fungus. And that also decreases, the tree's ability to uptake water and nutrients. One bright spot is while we trap all those trapping locations you saw, we also trap for this predatory clarid beetle. So this beetle actually goes out and consumes southern pine beetle. So you can see here is a clarid with a prey. And so this is what the immature stage looks like, and this is what the adult beetle looks like. So we're looking for both southern pine beetle and these clarid beetles in our trapping that you saw the sites. And so we haven't seen this. This is actually a picture from that mortality event in Dorchester County. So these trees were on the right-hand side, the right-hand picture, these trees were weakened due to a storm event. And then the beetles were able to jump across the road and hit these healthy trees over here. So these trees were healthy at the time, and they were killed due to that aggregation pheromone. So the good news is that there is some treatments available. It's not necessarily a chemical treatment, but you can do a salvage cut to stop the wave of the beetles moving through. And so typically, if you see here, this is an old picture from one of the original southern pine beetle brochures made by the Texas Forest Service. But you'll have this infested, area that the beetles have killed, the area that the beetles have moved into. And so what you do is you do a cut around the infested trees to kind of make sure that that pheromones that are moving back and forth that are bringing the beetles to the trees will have been impeded by taking out this salvage cut of a 50 to 100 foot buffer is typically what's recommended of these uninfested trees to make sure that we stop the movement of the beetle. There is limited chemical controls for southern pine beetle. Typically, it's something that would be used for a yard tree. It's not something that can be used in a forest system. And of course, always removal of high-risk trees is a great way to stop southern pine beetle infestations from even happening, such as lightning strike trees, trees that are dying due to saltwater intrusion or due to water flooding, that kind of thing. And so you don't typically always have to remove the infested wood. Pile and burning or even cutting and leaving the trees usually has about a 70% effectiveness in stopping the southern pine beetle movement. And so the good news is that in Maryland, in all of those traps that I showed earlier, none of them had any level of southern pine beetle that indicates that we will have a problem in this coming year. So while we did find beetles, it's typically normal for us to find about 20 to 100 beetles in a season. and for us to do surveys and to have nothing come of it. Like I said, the trees can withstand, as long as they're healthy, a moderate level of southern pine beetle, but this was a very low level of southern pine beetle that we caught this year.
I think we had a question on this topic before you move on is,
Yep.
Kyle Dingus mentioned his understanding is that southern pine beetle can really thrive in places that are overstocked or haven't been thinned. Is there a sort of changes in silvicultural practices, or are there best practices to have thinning so you reduce the stress on the pines?
Yes. Yeah. So perfect. So that's one of the recommendations that the U.S. Forest Service has. They have a whole program for thinning and to maintain that healthy stock level for forests, and as well as the New Jersey Forest Service has also done a lot of work showing that in the stands in New Jersey, once the stocking level has been reduced and that they're no longer overstocked in some of their wildland areas, then the southern pine beetle pressure is greatly lowered. And a lot of that, you think of it, is as trees are closer together, if they have southern pine beetles and those pheromones are going up, they'll find more southern pine beetles closer together. Whereas when things are sort of separated, again, it'd be like somebody breathing right next to you. If you're breathing here and somebody else is breathing here, you're going to feel them. But if you guys are separated, then you might not necessarily feel that breath. It's the same thing with the pheromones. So yeah, absolutely. Thank you for bringing that up. All right. So moving on. So one of the things that are causing damages to all of those areas that I brought up about southern pine beetle is saltwater intrusion. So one of the things that we do is we do a flight every year. So we get up in a Cessna and we have been flying grids across the mid to lower shore where we know of areas that are being affected by saltwater intrusion. And so what we map every year is changes that we have seen from the past year. And so in 2021, I left these up here so you could kind of see the difference or the similarities. So we saw 84,381 new acres that are being affected by saltwater intrusion. And then this past year, we mapped 67,000 acres. So not necessarily that this 67,000 acres is new, but all of it is new, but it is affected at a different level. And so what are the levels we're talking about is that when we're up in the air and looking at it, is the damage to the affected forest very light, or if it's very severe? So is the mortality only 1 to 3% of the trees in a given area, or is it over 50% of the trees? And so as you can see, we've moved to basically all of our trees have been in that very severely affected category by saltwater intrusion. And so basically all of the stands that are mapped here on this side have over 50% of their trees being affected by saltwater intrusion. And so what are we looking at from the air? This is a picture. Here's the landing gear from the Cessna that we were in. And so what we're looking at here, so those polygons, this might be a polygon here. And you can see, you know, what used to be a fully healthy forest has had march encroachment. And as well as, you know, you can start to see where it's encroaching in here, as well as you can see this is still pretty healthy, but then this area here is what is being affected the most. And so this is kind of the stuff that we're seeing in Dorchester specifically, but in the other areas is patchy forest remnants that are now being affected either by saltwater intrusion or by flooding. So that's something else that we're kind of keeping an eye on. And we're starting a partnership with some universities to see, to kind of try to quantify this in a more scientific manner besides just our aerial surveys. So that's kind of something that's interesting and for the future for the upcoming year. Spongy moth. So a lot of people think of spongy moth from the 80s and 90s, but it is very much still affecting our forests. Here you can see a female and male spongy moth. And if you're wondering, wait, what is spongy moth? It's gypsy moth. Lymantria dispar. So gypsy moth is no longer the accepted common name by the Entomological Society of America. So we have all moved on to spongy moth. So, and the spongy comes from these eggs. So these are all large egg cases from the spongy moth. And so basically spongy comes from when you touch them, they feel like they feel full and that they'll bounce back like a sponge. Not my preferred, but here we are. So what does it look like when it's not a moth or a egg case? This is what they look like. Here are the beginning stages of the larval stages of the spongy moth before they move into the larger larval life stages, where they have these blue and red dots along their backs. And so spongy moth is the only one who has those two colors. We have several other defoliating caterpillars in some of these spongy moth areas, and they will either have white spots or they'll have long white lines along the back. They will not have these same markings. So that is one way to be able to tell Eastern tent caterpillar and forest tent caterpillar from these, is that these specifically have these blue, when they're larger, they have these blue and yellow dots. And then this is what the pupal cases will look like when they're attached to trees. And of course, this is what we're trying to prevent when we're dealing with spongy moth, is the forest looking like December when it's actually June. So where did we find spongy moth? This year we had a lot of spongy moth populations in, so this is Salisbury here. So to the east of Salisbury, from basically from the Delaware border down to Pocomoke City, which is right here. So it's Delaware to Virginia to the east of Salisbury. And so you can see there, so this year we had 6,418 acres and 48 treatment blocks that qualified for suppression. And then we only sprayed 6,030 acres following the withdrawals from objectors. The contract winner this year was Bunting's Dustings, and they supplied us with this ag cat here. You can see this, and then these are what our chemicals come in. So this is 4A 48B that we used. This is an organic. It's Bacillus thuringiensis. It's a soil bacteria, so it only affects caterpillars. And so there you can see kind of our specifics for treatment of what we used. So in generalization, spongy moth suppression is typically now is typically done either with 4A. So there's 4A 48B, which is what we use, which is labeled organic with OMRI. And it's a soil bacteria. And then in addition to that, they have a 76B, which that is more concentrated and is sprayed at a third of a gallon per acre instead of a half a gallon per acre. However, that is not labeled as organic, so we haven't used that. In addition, Pennsylvania uses an insect growth regulator, Mimic. It basically causes the insect to shed their skins faster. And all of this is done with aerial suppression, because what we're trying to do is get to the caterpillars while they're small and inside consuming material in the canopy. And so it's really hard, obviously, to do that with a hose. It's a lot more efficient and effective when you're doing it with aerial suppression. In addition, homeowners for spongy moth can always do barrier bands, either whether it be with burlap or with a sticky substrate to try to prevent. The caterpillars do move up and down the trees every day, and so they'll prevent that movement and kind of stop them where they are. So what does it look like for this year? So unfortunately, it doesn't look great. So this year, this is a picture of a tree that was taken a month and a half ago in Allegheny County. And so you can see there's 1, 2, 3, 4, 5, 6 female moths laying egg masses, and you can see more egg masses to the north of the tree where the females are. In addition to that, this year we saw defoliation again in these areas from to the east of Salisbury, from Delaware down to Virginia. The good news is that only 756 acres of that defoliation that we mapped was inside of treatment blocks. And so the majority of our treatments worked and worked very well. In addition to that, we also saw the spongy moth fungus and the NPV virus, which I'll show you next, was found in a lot of these areas on the Eastern Shore. And so the good news with that is that that mortality with the mortality from our spongy moth suppression hopefully has decreased the number of egg masses for this coming year. However, so that's the good news. The bad news is that egg masses obviously have significantly increased in Western Maryland. And currently we're looking at an over 10,000 acre program inside of Western Washington, Allegheny, and Garrett counties. And this, of course, goes with, in the summer, we did male moth traps, and in our male moth traps, trying to predict the populations for spongy moth, all of our male moth traps saw an increase of population catches by up to 50%. So we're expecting a larger suppression program this year. Certainly less on the Eastern Shore, but more on more out in Western Maryland. In addition to that, I will say that there's a couple of hot spots. Some of those are in Hartford and southern Baltimore counties, and in addition to Frederick County. So those are kind of our hotspot areas for spongy moth. Now, the native spongy moth fungus, Entomophaga myrmica, that is a fungus that's in our environment. It's in the soil. When the caterpillars move down the trees, they'll come in contact with the soil. They'll pick up fungal spores. Those fungal spores will then go from inactive to active form. And then basically they consume the caterpillar from the inside out. And so then what happens is that they will die, and then they'll come up to these sort of, they'll attach themselves to the tree, and basically they'll just be a desiccated husk there. And so then the spores then are released from the body, where they can come in contact with other caterpillars that are now moving up and down the tree, as well as then fall to the soil, be in the soil for the next year. And then in addition to that, something else we saw this year was a nucleopolyhedrous virus, or NPV, for everybody who doesn't want to have that mouthful. So it sort of does the same thing. So the caterpillars will still consume leaf material to become larger and later life stages. However, when they die, they do die again on the tree, and then they'll go into this inverted V form. So while the fungus and the virus are great, unfortunately, they do not stop defoliation in this year. However, they do stop populations from turning into moths to have them populations for the next year. So they're great at controlling things. Typically, the fungus is something that can control caterpillars when they're in a small amount, a small number. However, once the populations really start to explode, then the NPV virus will take a couple of seasons for it to kind of expand within a population. But then usually the third or fourth year, then it'll be able to help control populations. So do we have a question?
Yeah, we've got a couple of questions. Do you guys do any control on private lands?
So we do control for spongy moth on private lands. It needs to fit into our spongy moth suppression program. So there's a couple of characteristics for that. So you need to be at least 25 acres, have at least 50% oaks or trees that are extremely susceptible to spongy moth. And so there's some characterization of the forest, as well as you have to have a pretty dense canopy. We can't just have single trees here and there because of the way that we spray our chemicals. If there's not a full canopy, then the amount of spray that we're using isn't going to be able to control populations without that canopy to be able to keep it there and not fall to the ground. And so certainly if you're not in our suppression program currently, you can definitely reach out to me. My contact information is at the end, and I'll put you in contact with your regional office. The regional offices are the ones who help make those determinations for if they fit into the categories of our program.
Cool. And there was another follow-up on cold temperatures and how long it has to be cold to kill the eggs. How long?
So Canada has problems with spongy moth, so it's just not that cold here to be able to take out those populations. I honestly don't have a specific temperature for you. But yeah, if it's not helping, if the cold isn't helping Canada, it's certainly not going to help us. So I can get you better information, but that's my my non-exact number.
Thank you.
Yep. All right. And so in addition to that, we don't only just look for European spongy moth, the Lymantria dispar. We also look for Lymantria dispar asiatica and so we do sample for 8 exotic Lymantria and Dendrolimus species. So these are larger moths that can come from the Far East and that have the ability to move with transport. And so the main thing that we're concerned about in Maryland, of course, is our Chesapeake Bay corridor. So there have been Asian spongy moth as well as rosy moth egg masses that have come into the port of Baltimore. And so these egg masses were viable. They had live eggs on them. And so typically what happens is the USDA, APHIS will come through and have a cleansing order, or if they are unable to cleanse and clean the ship, then they'll send the whole shipment back out. However, as most of you know, there's a lot of time that these ships hang out in the bay, as well as if you remember just last year, we had the ever forward, not go forward and be stuck in the bay for several months. And so that definitely had a chance for those populations to move off the ship if they happen to be there, which I'm not saying that they were there. I'm just saying that it was a great opportunity. And so we do these exotic Asian defoliator moths surveys. And so in this past year, we're just finishing up for this year, but in the past year, we sent off 327 adult spongy moths for analysis. And of those, 321 were returned as our Lymantria dispar, our European gypsy moth. And then the other 6 moths were unable to be diagnosed due to test failure. So that's pretty typical. So far, we have caught more moths inside of our Asian. So anyway, sorry, nomenclature is still the same. So it's still Asian gypsy moth for the Asian species, but so AGM suspects have been caught and then they've been forwarded for analysis, and we don't have the analysis back yet. In addition to that, we did see a small outbreak of cankerworms in Garrett County. So that those cankerworms defoliated about 102 acres this spring. And then in addition to that, other events that happened this spring was a late heavy frost and snow event, and that caused damage. Well, it caused damage, but it really, what it did was it delayed the trees. There's no mortality associated with this event, but the trees were significantly delayed and had some frost burn to them. And okay, I'll go back to the other slide, but here's the map of the frost damage. You can see here, a lot of it is around Green Ridge State Forest. And so all these blue areas are areas where the late frost and snow event had impacted developing trees. So that totaled to 24,019 acres this past year. And then here's where all of our Asian spongy moth traps are. So you can see we have them set up in some of our rail areas and some high population spongy moth areas, as well as along the canal here, and then all along the shipping channel to the Chesapeake Bay. All right, so moving on to, oh my gosh, I'm so slow. All right, so we'll try to move really quickly through these. So declining oaks. A lot of people have been curious about if it's oak wilt. So we've done a lot of sampling. So this is our samples from 2019 through this past year, 2022. And then what did we find? So basically for oak wilt, we found them in Allegheny County only, in areas that had previously been known to have oak wilt. None of these other areas had oak wilt. So then you can see here is bacterial leaf scorch. So we basically found that across the state. Diplodia canker, this is a bot canker. The majority of these that we found were Diplodia corticola. So it's something that's been found before, nothing new. And so that again could be found from Allegheny through the lower eastern shore. And then we also sampled when we were looking for oak decline for Phytophthora species. So this is soil root rot. And so you can see they definitely poked up throughout the state. And then was there a difference between what we found in white oaks versus red oaks? And yes, there was. You can see the majority of the bacterial leaf scorch we found was found in red oaks. And so, and then basically, and the same thing with oak wilt, we only found oak wilt in red oaks. And again, red oaks are more susceptible to oak wilt, so that's not terribly surprising. We found Phytophthora species in both red and white oaks evenly, and the bot cankers pretty evenly through red oak and white oaks. I will say that the Phytophthora species that we found was not Phytophthora ramorum. It was Phytophthora cinnamoni, as well as, for the most part, as well as a couple of other assorted native Phytophthora species. However, we do survey for Phytophthora ramorum. It used to be known as sudden oak death. So we do a stream baiting survey for that in areas of high risk. And so you can see where those were across the state, and all of those turned out to be negative. So this, in summary, we are still not sure what's causing our oak decline. However, it seems to be that there's a whole host of things out there attacking the trees. And then in addition, we also have looked at insect hosts. So not only do we have all those pathogens that are affecting our trees, we also looked for new oak pests. So we looked for an oak splendor beetle, oak processionary moth, and an oak ambrosia beetle. And you can see where we looked for those across the state in declining oaks, and we did not find any of these new insect pests. So no new insects, but a bunch of native diseases. So where does that bring us is that we still are unsure. We're thinking that it's a combination of environmental factors, the abiotic factors, moisture, temperature, as well as stressors from these pathogens that are causing this decline and mortality. So unfortunately, no smoking gun, but we are still working on this project. A lot of people would like to know about walnut twig beetle. So walnut twig beetle are these extremely tiny beetles here. You can see the noggin of Abraham Lincoln. So we initially found walnut twig beetle in 2013. What is bad about walnut twig beetle is that they cause a disease. They have a fungus inside of their mouths that they bring to the tree, which will cause these cankers. These cankers then coalesce and cause mortality in the trees. So this is where we had set up all of our walnut twig beetle traps. So walnut twig beetle has been found previously in Cecil, and then in this Baltimore City, Baltimore County area, as well as just on the other side of the border in Anne Arundel County. However, this year we did find a record in St. Mary's for the first time. So this is the first time it's moved outside of this area or this area since 2018. And so that was a bit concerning. It is inside of a power station. And so the trees are just outside of the power station, but it's on a power station property. So the likelihood that it actually was caused by introduction is pretty high. So currently we just finished our walnut health surveys, and currently all of the trees that even have, so the only place that we've seen the fungus consistently is in Cecil County, and all of those trees look extremely healthy. We just had a report yesterday that the branches that had some decline in them have basically been aborted by the tree and have fallen off. And so it's possible that mortality of walnuts in Maryland is unlikely due to the fact that these eastern walnuts are native here. And so they have a lot better ability to use their natural defenses to be able to fight off this infection and beetle versus trees that were out west, plant out of place. And so they didn't have that ability to pull from years of adaptations. And so that's the good news, is that we aren't seeing tree mortality and decline from this pest. However, as you can see, we are still surveying for it in all of our areas. Beech bark disease is pretty, it's a complex of scale, nutria fungus, and that causes bark damage. I'm just going to go quickly. It has only been found this past year in Garrett County. And in those trees, they're declining, but they're not dying. So there's a possibility for some resistance out there in the western area. The big news is beech leaf disease. So this is a disease that's associated with the nematode Litolinkus. It causes the stripes, this discoloration inside of the leaf margins. And so it also can cause aborted buds. Typically, the young trees have been dying within a year or two of their first infection, where mature trees have been able to live with this nematode for 6 to 10 years. There's no current approved treatment for beech leaf disease. So we've been surveying for it across the state, and we've also set up permanent plots where we survey trees every year, the same trees, and take health measurements. And unfortunately, this year we have found it. So you can see in the peach is where we've found beech leaf disease, and we've found a sample, and we've taken it to a lab and have it confirmed. The Anne Arundel and Washington counties, we're awaiting lab confirmation. We have taken samples. So unfortunately, we are positive for this disease. Since it's at the very beginning, we have not seen mortality yet, but it will be coming in the upcoming years. So we're kind of hoping that they're able to come up with a treatment program soon. Hemlock woolly adelgid. I know I'm like cutting in on time, but so we do have a huge hemlock woolly adelgid suppression. So we use imidacloprid. It is either done through trunk injections, which are just like the EAB, or they're done through soil injections. Here you can see are 2 different soil injectors. This is they're both liquid imidacloprid. This is an injectable imidacloprid, and this is a soil. So we use liquid imidacloprid 2F. Those are the 2 names, Curates and Easy Eject Light, of what we use. And in addition to that, we've also used Cortec tablets for small trees. We do only treat hemlocks that are within 50 feet of water with the trunk injection. So that way that we know that that chemical is getting into those trees and not into the environment. So in total, since 2004, we have treated 1,339,998 inches of DBH. And that is a savings of 124,891 hemlocks. So it's pretty impressive for our small crew. This past year, we treated 20,735 trees for a total inches of DBH. You can see here is 232,000. So that's just what we treated in this past year. And you can see this map up here. The majority of our heavy hemlock stands are here, but we do have stands across the state that we treat. We also release beetles. These are predatory beetles, Laricobius nigrinus and Laricobius osakensis. So you can see this beetle right here. This is what we're talking about. This beetle will come and consume HWA. And so in total, this past year, we released 4,320 predators. So here is a kernel density map, and you can see where the hotspots are, where we have released the most beetles. So here you can see our western region, our central region, and our northeast region. And then in addition to that, we also have released other types of predators of HWA. They haven't been as successful, but we have released them in the past. But the most successful is this Laricobius nigrenus, which is why we have continued to release it in large numbers. And so you can see there in total, our program has released a little over 34,000 of these LNs. So where have we've released them? Have we recovered them? Yes, we have. You can see here the majority, a lot of our larger recoveries have been in our Frederick and our central region, but we've also had fairly large recoveries in and around Cumberland. And we also have had some smaller recoveries in our Northeast area. So overall, a very successful program. We've also done hemlock restoration. So in areas that have seen a lot of their hemlocks disappear, we have been able to work with the Pennsylvania Department of Agriculture's nursery to raise hemlock trees. And so you can see here at Cunningham State Falls Park, each triangle is for a single tree. So it's really a pretty cool program to get hemlocks back in the landscape. Cyrex wood wasp, we do survey for this. It has not been found. You can see here across the state, we have not found it at all, but we have found some natives. And so these are the 2 natives that we have found, but we have not found any Cyrex noctilio. It is a wood wasp that affects pine trees specifically, and it has been found in New York and Pennsylvania and Maine, but not here, which is great. It seems to be extremely slow moving. So without human assistance, I'm hopeful that we won't find this in our state. In addition, we also have been looking for red bay ambrosia beetle. This is a beetle that brings with it the laurel wilt fungus. So it attacks sassafras, bay laurels, red bays, and has caused mortality in a lot of the South. However, we have not seen that here, which is great. And then finally, some additional pests we do track for beech bark disease, forest tent caterpillar, eastern tent caterpillar. Those we look for, like I said, inside of our defoliation areas. We also do a ton of other small hosts. So you can see in Washington County, we had some walking stick infestation in Allegheny this past year. We had cherry scallop shell moth, basically anything that's affecting forests we're trying to map. And then finally, Dorchester County, we saw a hail event in 2022. So that affected some acreage, as well as here's our saltwater intrusion. And then one of the other things is elongate hemlock scale. And so, of course, we've seen that kind of across our upper tier of counties. So if you're ever stuck in the mud, like I have been, we're definitely here to help and assist when we can. We are only 10 employees across the state, so sometimes it does take us some time, but here is my email and phone number, and I'm happy to assist.
Thank you, Heather.
Yep.
I learned a lot about entomology on that session, and was popping in like links to some of these species as you were going through, so to help other people. We're getting some comments coming in. We have a few questions that I didn't put out yet. I'm going to try to everybody feel free to add questions into the chat. I'm going to try and run through a few of them right now. So when you were talking about the ash borer, somebody, Brenda Beal, great volunteer in our Delmarva Woodland Stewards program. She's just an awesome person. She asked, is this our ash trees going the way of the chestnut? Is this a sustainable thing? Are they really just kind of like on life support at this point? And could you describe sort of the long-term thoughts about what's happening with ash trees? They're all dead in my back area. There are none left. So I'm curious, are we looking at functional extinction here?
Yeah, so yeah, pretty much. I think, with the work that a lot of us scientists are doing, we're also looking for a lingering ash. So there do seem to be ash that are inside of our susceptible varieties that have been able to kind of go the way of the white fringe tree and have some adaptations. And so currently there's researchers with USDA Agricultural Research Service that have been able to identify of the ability of these trees to be able to resist EAB. And so they're trialing those now. But, you know, for us here, certainly we're going to see, you know, 99% of our ash that haven't been treated to perish from this beetle. And so the ways to bring it back are, and to keep it here, or to keep the seed bank through treatments until we have enough parasitoids that have built up within the population to be able to control those beetles. I do not expect us to get to the, you know, square footage that we have seen in the past, but it certainly can be in our landscape in a much smaller quantity. Yeah.
I did see some early research on that. That's at least some hope out there. David Peterson asked I remember learning, looking into the various things that could be causing oak declines, and it's like oaks have so many things that go after them. I remember just being like, wow, there's a presentation with like 15 different insects that attack oaks. So I'm sure this is going to be a very hard question to answer, but David asked, what's the sort of level of risk by the various pests you mentioned in your presentation? I think you had some bar charts on the red oaks and the white oaks. So does this correspond to the level of kind of risk that you feel, or are there some other like hot ones that you think people should be aware of?
Yeah, so I think so for level of risk, I feel like for the red oaks is bacterial leaf scorch seems to be the one that we find more often than not. And then we thought that the diplodia or the bot cankers were going to be a bigger problem because there was a new diplodia that was discovered in some of our samples. However, it hasn't shown up again since. And so it was found, Diplodia querciferus was found and described in 2018, and we haven't been able to find it in our samples since then. So that I feel like has kind of like come back. Again, all of these things were characterized as secondary pests, something that, you know, could harm or be around when there's something else already affecting the trees. And so I don't think we've really been able to quantify in this kind of new world how much those are going to actually affect our trees when before they weren't affecting them as much, or these trees were healthy and able to withstand these infections. Or, you know, even beetle presence. Certainly there's a lot of different types of Agrilis that could affect, or Agrilis or, you know, flat-headed, round-headed borers that attack oaks, and that the trees could easily withstand, kind of like what I was talking with southern pine beetle, but it just seems like now they're not able to. And so I don't really think we have a good handle on, or even if there's any research currently on those old secondary pests, if they're going to be causing larger future issues. And so unfortunately, I don't think I really have a good like number system for you for that. Just that what we are seeing, which is that these secondary pests are affecting the trees, or that they're in trees that are in major decline, we're able to find them. But in addition to that, I will say Malaria root rot seems to be causing a lot of problems. And that's one that we haven't really been doing a lot of survey for, because it seems to be in a lot of our declining trees. And so definitely Missouri has seen a lot of it. And so that could be another one, I think, that I didn't mention that could also be affecting our forests.
Right. Thanks. Yeah, I've actually noticed like sometimes just minor damage to the bark. And I was looking up the diplodia or the
diplodia.
It seems like also it's like it can maybe be living on the bark harmlessly for a long time, but if there's a damage or some sort of scar, it can infiltrate into it, cause trouble. And I've seen that with a neighbor had a gash in the base of a tree from some construction equipment. Didn't seem that bad, right? But that whole tree is a nice big majestic oak. So be careful to bark on your oaks. You know, if you're doing any construction work or anything else, like those wounds can lead to things getting into them. So great. Let me see. We had one question about Asian longhorn beetles. Are those around here?
So no, we don't have those. Isn't that great? So Asian longhorn beetle is an Asian, it's a beetle of Asian descent, and it's currently in South Carolina in breeding populations, and it has been found in Massachusetts, Ohio, and New York. And so New York has been declared eradicated. And so the good news is with Asian longhorn beetle, as long as you can get into a population when it's still initially establishing, eradication works very well. And so the USDA Animal Plant Health Inspection Service has been able to eradicate several populations. It's not pretty. Asian longhorn beetle has a very large host range. And so a lot of trees have to be sort of cut down for the cause. However, they are able to get those populations extinguished with removals and trapping. And so we are going to be surveying for Asian longhorn beetle in the next year in 2024. We've just started the process for looking at those. Trapping is not great. And so we won't be doing trapping, we'll be doing visual surveys. And so this is mainly in maples that we're looking at. They are the preferred tree of Asian longhorn beetle, even though it does have that extremely long host range list. So we will mostly be surveying for maples and looking for signs of Asian longhorn beetle. It is very cryptic, even though it is very large. They typically are in the upper parts of the trees first. But like I said, the good news is that we don't have it. And that if we ever find it in the future, I am really hopeful for its eventual eradication.
Cool. There was another final question. If anybody has anything else, please pop it in. Last call here. And thank you, Heather, for staying on a little bit long, and for all the who are staying on past the 1 o'clock hour. But we did have somebody ask, oh, how many parasitoids are you releasing? Are they self-sustaining populations, or is this the kind of thing we'll have to continually put out new parasitoids?
So currently we're releasing about 800 of the egg parasitoid, the oobius, per site. So you saw we had 6 sites for oobius this year. And so, 6 times 800, that's how many of the egg parasitoid released. And then as far as the larval parasitoids, right now we only have 1 site approved for those. And so that's about 5,000 parasitoids released this year. And so we do releases for 2 years of these, same amounts of numbers each time. And basically they do seem to be self-sustaining at this point. Those recoveries that I talked about have been continuing on. And so a lot of those are being done in places where we haven't currently been releasing. So we're not catching what we've released, we're catching what's been there from previous years. So it's not, they are self-sustaining. Where we go from here, as how far out is really up to the researchers.
All right. And I know there is a long process for reintroducing those parasitoids and making sure that they don't cause more problems. So if anybody's here listening thinking, well, might we cause more problems by bringing in natural predators? There's a long process of testing to make sure that they're not going to cause additional problems, right?
Yep. Yeah, there's a whole federal process for that. And if you're ever interested, there's a couple 100 pages worth of finding of no significant impacts. That was part of an environmental assessment done for each parasitoid. So if you're ever interested, all you have to do is Google FONSI or EA, which stands for Environmental Assessment of Emerald Ash Borer Parasitoids, and you will find it on Google.
I bet. Well, Heather, thank you. That's all. We got a lot of thank yous coming in. It was a great audience. Thank you, everybody, for coming. I hope you learned something. Look forward to seeing you next month, where Bob Long is going to be talking about wild turkeys. We'll be moving back to the vertebrates and game species. So we've got some applauses. Thank you, Justin. Thank you, everybody, for coming. We will see you all next month. Thank you, Heather.
Yep. Thank you.